This is video 1 from Unit 9, Lesson 1. This is the first video from Unit 9. Unit 9 talks about radicals. And in this first video, we're just going to talk about simplifying some radicals. Okay, so first of all, a radical is a number with this square root sign. And technically a radical can have any root. It doesn't have to just be square, but we're only going to talk about square roots. So this is a radical. The number underneath is called the radicand. Okay, so when we're talking about square roots, it makes sense to talk about perfect squares. So perfect squares are these numbers 1, 4, 9, 16, 25, and those come from squaring your integers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. So these are the important numbers. These are the numbers I'm going to use to simplify my radicals. Okay, so first of all, if I look at the square root of 64, well, 64 is a perfect square. It is in my list. So since it's in my list, I can do the square root, and I just get 8. I don't have to worry about plus or minus 8 here because the radical is already drawn for me. So right now we're just talking about positives. It's just 8. So square root of 64 equals 8. Not square root of 8, just 8. Okay. To simplify other numbers, so for example, square root of 27. Well, 27 is not in this list of perfect squares, but it can be simplified. Think about simplifying radicals like reducing fractions. So square root of 27 can be reduced. And I use this multiplication property. It just tells me that I can separate factors. So if I have a times b, I can separate that to a times b and square root. All right, so what I need is the largest perfect square that goes into 27. That means divide. So I start at the bottom of my list because I want the largest. Okay, so start at the bottom and work your way up. So can you do 27 divided by 144 and get a whole number? No. So all of these are out because they're bigger than 27. Okay, you can do 27 divided by 25. No, not a whole number. 27 divided by 16, not a whole number. So until we get to 9. All right, well, square root of 27 is the square root of 9. So I'm going to list the perfect square first. What is 27? It is 9 times 3. 9 times 3. So these are equal. 27 equals 9 times 3. Now I can use that multiplication property and separate my factors. So I can separate the 9 and the 3. And then square root of 9, I know is 3. So that 3, square root of 9 is 3, so that can come out. And then the square root of 3 I just have to keep inside. So square root of 9 is 3, that comes out. And then this just has to stay put. So my answer is 3 square root of 3. So if you were to type in square root of 27 and 3 times square root of 3 in your calculator, you get the same decimal. Those are equal, they're just reduced. So it's like having 2 over 4 or 1/2. Those values are the same, one is just reduced. Okay, we also can use this division property. So if we have a fraction, we can do square root on top over the square root of what's on bottom. Okay, we're going to do some more examples. I recommend writing down this list just on the side of your paper so you have it there to look at. If we finish writing these out, just maybe you want to write this to the side too. 5 squared, 6 squared, 7 squared, 8 squared, 10 squared, 11 squared, and 12 squared. So usually past 144, we don't do those. I mean, you could do 13 squared, which is 169, 14 squared, and so on. Okay. All right, so square root of 98. Let me write our list down. So like I said, it's helpful to have this written down to the side. 64, 81, 100. Okay. All right, so I want to find the largest one of these that goes into 98. 98 is not in the list, so I'm not going to get just the whole number like I did with 64. Okay, so I start trying. Start with the one smaller than 98. And you can use some common sense too. Like, you know that 98 divided by 81 is not going to be a whole number, so you don't have to try that. 98 divided by 64, no, that does not work. 98 divided by 49, okay, that works. You get 2, you get a whole number. So I want this one. So I'm going to rewrite 98 as the square root of 49, and when we divided, we got 2. So 49 times 2 equals 98. Okay, then separate. 49 times square root of 2. And then we can take 7 out. Square root of 49 is 7. Then that square root of 2 is just stuck. Okay, 7 square root of 2. Okay. This is going to be the same thing. I just want to keep that 5 out front. So a number next to a radical means multiplication. So I'm going to write it like this. So I'm focused on the 48, and I want the largest perfect square that goes into that. So this would be a good time to pause and try to figure it out. It is 16. 4 does go into 48, but it's not the largest number. It's not the largest one from my list. It is 16 is the biggest. And it's 16 times 3. So I'll separate. And then I can take the square root of 16, which is 4. And since five and 4 are both outside the radical, I can multiply those together. So 5 times 4 is 20, and then square root of 3. So if you have a number out front, just leave it out front till the end, then you can multiply what's outside together. All right, these last two are the division property. So what it says is that I can separate numerator and denominator. So I can write this as square root of 16 over square root of 25, and then simplify each one. All right, square root of 16. 16 is in my list. That's just 4. Square root of 25. 25 is in my list. That's just 5. So this answer is just 4/5. Okay? For this one, so let's do the same thing. Square root of 60 over square root of 81. Okay, 60 is not in my list, so I do the same thing that I did with these first two, the 98 and the 48. I need to find the number from the list that goes into it. So it's not a perfect square, but it has a perfect square factor. So start with the ones less than 60. So 49, no. 36, no. 25, no. 16, no. 9, no. And it's actually not until 4. It's actually not until 4 that it works. So I can rewrite 60 as 4 times 15. I'm just leaving the denominator alone for now. Okay, so square root of 4 times square root of 15. I can separate. That's 2 square root of 15. And then if I look at my square root of 81, 81 is in my list, so that one's just 9. And this is how I will leave my answer. So 2/9, if you could, you would reduce those. So if this were like 2 over 8, we'd reduce that to 1 over 4. You cannot reduce the 15 and the 9 because the 15 is under the radical. So only things you can combine that are outside together or inside together. Okay, you ready to do Unit 9, Assignment 1?